Hi, I would like to do 2 examples of stoichiometry with 3 steps. So the first one, as you can see here, given the equation, lithium nitride plus water yields ammonia and lithium hydroxide. So we want to find if we are going to react 0.38 grams of lithium nitride, how much lithium hydroxide will we get? So this requires 3 steps. We're going to go from here to here. This is a mass and this is a mass. So here is our flow chart. We're going from mass of our given quantity to mass of our wanted quantity. So the first step would be to convert the mass to moles. Using the mole ratio in the balanced equation, we'll switch from the moles of the given quantity to the moles of the wanted quantity, and then switch from moles back to mass. In all stoichiometric calculations, we have to always use the mole quantity to convert from one substance to another. So, we're going to start with the given amount, which is 0.38 grams of lithium nitride. Our first step is to convert that to moles of lithium nitride. So if I set up my parentheses, grams of lithium nitride we want to cancel, so that's going to go in the denominator. Grams of lithium nitride, and on the top, moles of lithium nitride. So, using the atomic mass, or the molar mass, the molar mass of lithium nitride is 34.83 grams per mole.
So it sounds like you're potentially in suburbia yourself. So see if you any of this resonates with you.
Now I'm going to use that in this conversion. 34.83 grams is going to go with the grams. That's going to go in the denominator this time. Not always, but this time. Per every 1 mole. So to convert from grams to moles, we divide by the molar mass. Now we have to convert from lithium nitride to lithium hydroxide. So we're going to cancel out moles of lithium nitride, and we're going to convert to moles of lithium hydroxide. And here I'm going to use the coefficients from the balanced reaction. There's a 1 in front of here, even though it's not written, and there's a 3 in front of here. So it's 1 mole of lithium nitride will produce 3 moles of lithium hydroxide. I'm going to put in those numbers. 1 mole of this will make 3 moles of that. And now, in the last conversion, I have to go from moles of lithium hydroxide to mass of lithium hydroxide. So I have to convert back to grams. So last parentheses, I'm going to cancel out moles of lithium hydroxide, and I'm going to convert to grams of lithium hydroxide. In order to do that, I once again need the molar mass, this time of lithium hydroxide. And the molar mass of lithium hydroxide, which come from the periodic table, is 23.95. Remember, these values come from the periodic table, simply adding up the atoms that make up these substances. Okay, so 1 mole of lithium hydroxide for every 23.95 grams of lithium hydroxide. Now, we'll see that all of the units will cancel out except the units that we want. So grams of lithium nitride cancel. Moles of lithium nitride cancel. And moles of lithium hydroxide cancel, leaving us with the desired units of grams of lithium hydroxide. Everything will cancel diagonally. Anyhow, now all we have to do is type it into the calculator. And we type it in like this, 0.38, then we type in each fraction, times 1 over 34.83, 3 over 1, and 23.95 over 1. And there we have it. So, 0.38 grams of lithium nitride will produce 0.78 grams of lithium hydroxide. So that is a mass-to-mass calculation. You have to turn them into moles, convert between moles, because this is the only connection between the substances, is the balance reaction. So we need to use these coefficients. And then after we convert to the other substance, you can go back to grams. Let's try this one more time, but this time with, instead, volume. Given the equation, ammonium plus chlorine gas yields nitrogen plus hydrogen chloride. The balance reaction is there for you. And this time we're dealing with gases. So, let's look at this flow chart. We have the volume of gas at standard temperature and pressure. All gases, all ideal gases, will be exactly 1 mole of that substance, 22.4 liters. So in order to convert from volume to moles, we're going to divide by 22.4. We're going to use the middle ratio, and then we're going to multiply by 22.4 to put it back into volume. So 1, 2, 3 steps here. Now this is standard for all gases, and I'll write that down. All gases are 22.4 liters per 1 mole. So let's start with our given amount. We're starting with ammonia, which is right here, and we're going to finish with nitrogen, which is right here. So start with 13 liters of NH3. Our first step will be convert that from liters of NH3 to moles of NH3. And the ratio we use here is 1 mole per every 22.4 liters. Now that we've converted it to moles, we will convert it from moles of NH3, which is our given amount, to moles of N2, which is our wanted amount. So we're going to cancel out moles of NH3 in the denominator, and we will put moles of N2 in the numerator. The ratio here is 2 moles of NH3, so the 2 goes in the denominator, per every 1 mole of N2. And then the last ratio, we now have moles, and we need to get back to liters. So, once again, all gases follow this ratio. So we're going to cancel out moles of N2 to get liters of N2. And that's 1 mole of N2 per every 22.4 liters of N2. So, in order to convert this, let's make sure that all the units cancel. Here's your liters of NH3, canceling. Here's your moles of NH3, canceling. Here's your moles of N2, canceling, leaving us with liters of N2, which is what we want, liters of nitrogen. Anyhow, let's type it in. 13, first parentheses, 1 over 22.4, next 1 over 2, and next 22.4 over 1. And our answer is 6.5 liters. of nitrogen gas. So the key to doing these is to remember this flow chart, have it available to you when you complete this, and find what you're starting with and find what you're ending with, and just follow the path to the other side.